the main advantage of Tinkercad is that it is totally free, that you can set up your classes, you can assign things, you can actually make some projects, and of course the only problem is that your students cannot actually collaborate. For those familiar with Tinkercad, students can collaborate in 3D designs, but not in circuits. So I will explain why I have chosen Tinkercad for my virtual electric circuits. The reason is that when I find something online, it's easy to simulate it on this environment and then actually build the real world thing. And as far as I'm concerned, in the last Science on Stage festival in Cascais, Portugal, everything that I presented there, which was a control moment gyro, were designed, I mean the electronics were designed and coded for in this environment. So I will, before I go to Tinkercad, I will show you just an example of what I mean. Okay, so this is what I found online. And I went to Tinkercad and simulated the circuit. So I was pretty sure that it is working. As it uses this IC 555 timer integrated circuit, I knew that everything that was okay on my screen would also be okay on the real world. So I'm going to show you my. I have to switch back. So this is the actual circuit. Just a few. I don't know if you can see it. It's just a few wires, and I will just connect it. It's a red and blue light, like a police light. 4 resistors, 1 capacitor, 1 integrated circuit, and 2 LEDs. And of course, 1 battery. So I'm now going to Tinkercad. Okay, this is the environment. I will show you all the menu. On the right hand side, you can see a list of components, and you can also have some starters. Starters stand for ready circuits that you can use, and like this LED, for example, LED light up, and you can put more on your screen. They will work at the same time. So now we have 4 different circuits. If I try to move one of them, it will be a little bit distorted, but I can move everything. If I click on some empty space, I can I can move them all together. I can zoom in or zoom out by using my mouse wheel. And if I have something like this. The easiest way is going here on the left-hand side, zoom to fit, and make things appear normal again. Of course, I can. I have undo and redo. I can click on some component like this coin battery, and I can delete it. I can delete everything actually. Of course, I can just I can to make sense for my project. I can choose a different name, or I can just click on the Tinkercad logo, and all my work will be saved in my account. I can have access from any computer. I can log in, and so I will go and make a completely new circuit. As you can see, circuits with this name have been already saved. Just make sure that every time you log in into your account, you either choose Autodesk account, or you log in with your Google or Facebook or Microsoft. But if you create something when using your Google account, then and then you log in with your Facebook account, this will be two different accounts. Everything you have created will have been saved, but to find it again, you have to log in with your same account. And of course, you can create your classes here, and by declaring in the software's options that you are an educator. So, okay, I will create a new circuit. In my short presentation, you will find some information regarding LEDs. I like LEDs because they're colorful, they're very attractive. You can make a lot of different projects. And okay, so I just clicked on this LED and put it in this area. I can change the name. For example, I can make it L1, and I can also change the color. What you have to keep in mind here is that Tinkercad deals with all LEDs like they have the same forward voltage, and that means that they are about 2 volts. So no matter if this is green, yellow, orange, blue, or white, red or white, they have the same voltage. This is in real world, this is actually not true, because blue and white have more than 3.6 volts forward voltage. So the coin cell battery is almost enough to light them. But for any LED, you need at least a voltage of 1.2 volts, and you should not exceed the drop voltage, because you will make their life quite short. Or you can end up with burnt LEDs if the voltage of the battery is too high. I will also use this coin battery. I can get here, give the battery a name. If I want to turn it, I can either use this just under the Tinkercad logo, or I can use the R. I can type R on my keyboard. As you can see, I have this plus sign and minus sign. They stand for positive and negative, and LED has also cathode, which stands for the negative electrode and the negative connector or terminal, whatever you might call it, and the anode that stands for positive. I have to connect positive, as I will do it again with escape. I go back to what I was doing. So by clicking here to positive, I go up, and if I want to turn, I release the button, and then I click again and go all the way to anode. I can make it the lines straight. Of course, you can do something like this if you want. But if you have a lot of wiring, then you end up with something that it's not easy to work with anymore. So I have this line, and okay, I changed my mind, and I want to make some turning points. I will choose some intermediate point and double click. So I can do this. By double clicking, I create a turning point. If one of these points is not needed anymore, I just click on this point and press delete, and it's gone. For practical reasons, I want to follow some kind of color code for the wires. So I will choose red for the positive, and then I will connect another wire, which will be black for negative or for ground. Of course, you can choose the colors you like, but I think that at least for positive and negative, red and black will be the best choice you can make. If this point that where the wires overlap is not a connection point. The only connections are what you see. So now I will go and start the simulation, and I get a warning. This stands for information. It says that current through the LED is 61.9 milliamps, while recommended maximum is 20 milliamps. So the usable lifetime of the LED may be reduced. What I have to do is grab a resistor. I can connect it either to ground or now I can. This is 1 kilo ohm. I need a resistor that is a little bit, not a little bit, much lower, but I will start the simulation. It somehow lights up. I have some I have a voltmeter and well, this multimeter can be used as amperage meter or resistance meter, and I will make this ammeter and this voltage. As you know, when you want to connect it as an ammeter, you disconnect the positive. No, this is, it didn't change. Okay, amperage. And then you if you disconnect ground, then you continue with ground. For example, if I don't want this kind of connection for any reason, I can and then I will this is the same. And I will, if I click on code here, I get a warning that I have no programmable components like Arduino. So I will start a simulation. It says that I have a current of only 1.16 milliamps. That's very low, but I can, okay, maybe I can have, I can change the resistor. For example, I can make it something like 50. It's to I cannot, although I can choose any value for my resistor here, this is not what can be done in real life, because unless we are, for example, we're manufacturing something like an iPhone, or we're a space agency or some research center, we have access to certain values. That you will find a list in the presentation, my presentation, of what you can buy. For example, you can have in this range, you can have 30 ohms, 33 ohms, 36, 39, or 43. So we are going to use 43. It's very good, because this is what is available when you go to an electronics shop. I will also connect the voltmeter. I have to stop simulation. if you connect the voltmeter in an opposite way, it will just show minus the voltage. I will start simulation again. It says 2.06 volts, which is fine for this LED, and the current is also fine. So I want to change the name, maybe include this circuit in my projects list. I will call it LED with voltmeter. In this environment, of course, you can choose what resistor you might need and so on. I will stop. As you can see, the name has been changed, and if I want to make an annotation of what I have done, I will put a note here. For example, I can write that LEDs are considered to and resistors. I can do the same for the resistors, and resistors are tri-band. Of course, they follow the color code. As you can see, when I change the value for the resistor, the colors here change. You will find the color code in my presentation as well. And they have an extra band, which is usually silver or gold. And gold stands for 5% tolerance. That means that this resistor, which was 43 ohms, might be anything between almost a little bit more than 40 ohms to a little less than 45. But okay, I have, I guess there are no questions so far, or are they? Daniel, I cannot see my screen, so please, if there are any questions, let me know.
Yeah, there have been no there have been no questions so far.
Okay. Yeah, we'll go back. Okay. I think I will show some. This was a very simple circuit that we can add, of course, some switches. We can add a potentiometer, and I will directly show you some of the circuits I have already assembled here, just to save some time. As you saw, I chose this circuit, and I can click on Tinker this. I saw in comments that the LED will not light with this with the first resistor of 1 kilo ohm. Well, that depends, because we use if we make for example, a potato battery, and by potato battery or lemon battery, I mean an array of at least four potatoes with zinc and copper electrodes that are connected in series. And although the current is very low and the total resistance is very high, the LED will light, but of course it will not. When I said that the LED will light, I don't mean I didn't mean that it will be bright. It will just show that a very small current passes, and this is also how we test LEDs by using a multimeter. We connect the positive and negative terminals with our multimeter, and there is just a very dim light, but it is just enough. It will not work for white LEDs for sure, or blue, but for red, it is a way to test your students' lemon or potato battery. I will just I have this circuit. This shows how we can change a DC motor direction. I can start simulation. I have two switches, like this switch, slide switch, and by doing this or by doing this, I have when it says that the motor runs at 17,568 revolutions per minute, and the plus sign in front of this number means that when we look at the motor from not from the terminal side, but from the front where the axle is, it will rotate on a clockwise direction. We stop, and then it's counterclockwise. I just connect the common terminals with positive and negative, and then the others I connect terminal 1 and terminal 2 to the two terminals of the motor. You can connect this motor. This is actually this is not positive. Maybe it's marked with a red color, but it's not positive. It's just terminal 2, and it means that if it is connected with positive, the motor will turn clockwise. Otherwise, it will turn counterclockwise. Okay, I will go to some programmable circuits. For example, I will use this. Okay, now we have an Arduino Uno R3. This is the most common Arduino. I think and one of the cheapest you can buy. As you can see, I have connected. I have here on the top. I have digital pins from 0 to 13. So I have 14 different digital pins. The digital pins can either supply low, which stands for ground, or high, which stands for 5 volts. An Arduino can be powered in different ways. You can power it and code and upload any code you have created by using a USB cable. But you can also power it by using V-in, which you can use any voltage which is at least 6 volts. Or if you have a stabilized power supply, you can supply directly 5 volts. Of course, if the USB cable is connected, you can get 5 volts from this terminal. And you can use a barrel connector. It's a 2.1 millimeter connector. And you can connect a 9-volt battery by using this. The digital pins also work like analog output pins. For example, those that have this sign in front of them are PWM, or pulse width modulation pins. That means that, well, I can show it by using, you can go here and I can I will zoom. No. I will use an oscilloscope and I will connect negative pin here. Well, I have to. Well, when now it seems to have lost connection with the Autodesk server, so I will go to Tinkercad logo and click on it. So everything that I've done so far will be saved, and I will start over from the point I had left the circuit, as you can see. So every time you find it difficult to do something, even in coding, that might mean that no, it didn't work not this way. So, and I will take all the pins except those with this little sign can supply either ground, which is low, 0, or high, which is 5 volts. The others can supply anything between 0 and 0 to 5 volts divided by 255. That means that you can have steps of 5 volts. It's actually an 8-bit So, okay, I can. If I start my simulation, and I can, you can see, you can change this from here, and in this circuit I have also used, this is supposed to be a night light, something that uses a light-dependent resistor. If I click on the resistor, I have a slider, which means that you see the pulse here. And of course, just to explain this a little bit, for example, if I have pulses that for, let's say, 10 seconds, I have pulses that last for 1 second, and I have 5 of those pulses. 5 pulses of 5 volts that last only 1 second in a period of 10 seconds. That means that we have a mean voltage of 2.5 volts. Here I can it is supposed to, this is I will stop the simulation, I will take it. And I think you can now see this is supposed to be dark, this is supposed to be full bright. And my LED is lit when it's dark. Under some conditions that are have been set in this code, I will show you how to code for the Arduino in the next example. Okay, this is, I will create a circuit from the beginning. What you should not ever do is directly connect a DC motor on your Arduino, because DC motors require much more than the 40 milliamps or any given digital output. Of course, you can limit the current by using a resistor. I will take this servo motor, which is very useful in robotics, and I will also use a potentiometer, and I just want to turn this. I will supply voltage, and I will ground will be applied here. Of course, you can apply ground, you connect the ground to terminal 2, but then it will, your potentiometer will work in an opposite way. And here I will connect 5 volts to this terminal. And this I will just go and connect it to before I connect the servo motor, I want to make some code and read the values from my device. This is supposed to have a voltage between terminal 1 and terminal 2, a voltage of 5 volts. And by connecting the wiper to any of the analog pins, I can take anything from 0 to 5. So I will go to code. This is something that is about the built-in LED, so I'm not going to use it. I take it here and it disappears, or I can take them. I can put everything in the dustbin. It's the same. As you can see here, I have blocks. For those familiar with Scratch, I can also have blocks and text. So I can actually program with blocks and see what I have done in the Arduino programming language, which is a dialect of C++. It's not real C++, but it does have a lot of differences. So you can become familiar with programming in C++. But you have to remember that if you switch to text only, and then everything you have done in blocks will disappear, but you can make changes in text. But then you can also you cannot go back to blocks as well. So here, let's say that we'll take this, which is print to serial monitor. What we want to print, it's let's read analog pin A0. This is the easiest code we can write. I click on code, and of course the simulation has started, but nothing happens here. But the only thing that you can see is that the on LED is lit. I go back to code and I click on serial monitor. As you can see, I have this values 0, and for a serial, I will change this. I will stop simulation. I will change to blocks, and I will start simulation again. And as I move the wiper, I get values from 0 to 1023, which stands for 5 volts. So I have little steps of almost 5 millivolts. And this is what I can read in serial port. Of course, serial port and what I had done here is, for example, if I have the text, okay, blocks and text, I will not change anything. But this, I can just copy and paste my code in Arduino IDE programming environment, and just go from the virtual environment to the real world. Okay, I will now go and connect my servo. If for small servos can be connected directly to Arduino, but if you have a very large servo, you should better connect it with an external power supply. that will be capable to deliver the power you need. This is ground. This is a very small, and okay. Remember, you go straight, you release, you click again, and then you go to 5 volts. I will use red or maybe orange to, and I have signal which has to be connected to any of the PWM pins. Like the first of them is number 3. That will give the right pulse to make it to control speed and the direction of the rotation. These are the most common servos, but you can also find if you want to use them in position of for a small robot to as DC motors. You have to buy 360 or full rotational servos, which are actually not servos because you don't know the exact position. But with if you send, for example, a 0, it turns it fully turns in one direction. If you send 180, it fully turns in another direction. And if you send 90 degrees, I will show what I mean. It stands still. So now I will go back to my code, and I will, if you remember, I had set pin number 3. I don't need this anymore, but I need this. I will put this here, this. So I set pin 3 to read analog pin A0. Okay. Let's start our simulation. If you can see here, the behavior of my servo is a little bit problematic because the serial monitor, I had from 0 to 1023 different values, but my servo reads only 0 to 180 values, and because these are the degrees that it can rotate. So I have to make some kind of, I have to appoint to from 0 to 1023 to appoint these values to 0 to 8 to 180 degrees. What I will go here, I will use this map, and I will put it here. So I will map what the analog read of A0 to the range of 0 to 180. And now I'm good to go. I press code and I start simulation again. So now, as you can see, this is for 0, and as Okay, sometimes the simulation might not go as planned because like today I have some unstable internet connection, not all the time, but sometime. But as you can see, the servo now behaves like it was planned to. It doesn't go all the way, but it has some. So this is you can use this is just a block of code which is represented by this C++.